Hello class, I thought to create a short video on how to create a linear regression model on Google Sheet. So the question 19 of your review package for exam 1 has the data from an activity we did in a Math 103 class, a statistics class at Miracosta. Students wanted to predict how many chickpeas would it take to cover the length of the class. So they conducted an experiment. They line up 2 dry beans on a ruler. They measured the total length of the row of 2 beans to the millimeter and recorded the results. They added another 2, so they had a total of 4 beans. They measured the length. They did that up to 20 beans and they recorded the length in millimeter, as you see on this table. So what we're going to do is we're going to construct a scatter plot where y is going to be length versus the x, which is the number of beans, which makes sense because number of beans is what determine the length. So number of beans is independent variable and the length is the dependent variable. So to do that, you download the data from Canvas, you open it on Google Sheet. So we highlight both with title. We're going to go to insert, we're going to go to chart, and by default it shows us a histogram, which we're not interested because we're looking at bivariate data. So we want to create a scatter plot. So we go down to a scatter plot. So we graph the scatter plot, and looking at the patterns that we see, it seems that those dots comes very close to a line. So let's see if we can fit a line. So on Google Sheet, you can go to customize. You click on the graph on the scatter plot. You go to customize, then you go to series. Let me go up and click on the series. You go down on series until you find the trend line. The trend line, it fits a best fitted line into the scatter plot we have. So that looks like all the data comes very close to that point, to that line. So we go down because we also want to see the equation of the line. So where it says label, click on it, it says use equation. So now we have the equation of the line. Also, you see it says show R square, which we will use it in just a second. So let's make both of those available. So we have length equal 13.2x plus 0.467. The coefficient of x is the slope. The 0.467 is the vertical intercept. So going down here, it says find the equation of best fit line, which we found according to this Google Sheet. What is the slope? A slope is 13.2. The slope was change in y over change in x. So we are looking at millimeter per bean. So 13.2 millimeter per bean. So that means on average, if you add a bean to this rows of beans, on average the length increases by 13.2 millimeter per beans. Next question has to do with the Y-intercept. What is Y-intercept? Y-intercept is when x is 0, where the line intersects the y-axis. So if you look at that point, the Y-intercept or vertical intercept is 0.467. So that means when x is 0, that means when there is no beans, the length is 0.467. So you're going to ask yourself, how is this possible? Remember, this is the equation of a best fitted line. It's not the actual data. This is the line that comes very close to all the points on the data, but it might not give us the exact data. So this best fitted line has a y-intercept, which is 0.467. So going down, what is the coefficient of determination? Find the correlation coefficient. To do that, because we have R square, we can take the square root of it and find it. But let me move this. I'm going to show you another command in Google Sheet. So if we want to find, let's say we want to find R, what we're going to do is we're going to use the command correlation. So you see it says co-RREL. What we're going to point out the X variable first, comma, the Y variable. We enter it, we get 0.99989. Remember, correlation coefficients that are very close to 1 or -1 shows a very strong relationship. And here R is positive, therefore we are looking at a very strong positive relationship between number of beans and the length they form. Go to the next line. It says, what is the coefficient of determination? So the R square, which is right here, is equal to 1. R square basically explain what percent of the variation in the length is explained by this model. And we notice is very much 100%, which another way to find it, the R square, you can do very much a square the R. So you take this one to the power of 2, and you get 0.997836, which is very close to 1. So that means this equation is able to explain 100% of the variation in the length. And that shows that the line is a very good model to fit the data. So this best fitted line is a very good model. Is a linear model is a very good model to explain this relationship. What is the standard error and what does it mean in the context of the problem? So I have given you a handout where it takes you and helps you how to calculate the standard error. So you see number 13, we're going to use the set y-axis to calculate on Google Sheets. So we got another one. So we want to find SE. We're going to type in, as we saw here, we're going to type in STEYX, the standard error, and we're going to highlight the X variable. So we're going to highlight this one, comma, this one. So we get a standard error of 0.0944. So the standard error shows the average distance of the actual data from the prediction made on the line. So on average, those points, which seems very close to the line, are 0.09 millimeter away from the line, which is a very small number. You want the standard error to be very small because that shows your best fitted line very much comes very close to all the points you have. And that's a very good standard error for this data set that we are looking at. Next, we're going to create the residual plot for the data. All right, to create the residual plot, what we're going to do, we're going to go back and using the equation of the best fitted line that we have, we're going to create a column. So this is the actual length. Let me put the actual length here. And we're going to see what would be the predicted length. So our model, what does it predict the length to be? So what we're going to do for this new data set, we're going to create a formula. So using the equation of best fitted line, what we're going to do is we're going to have 13.2 times click on the X variable plus 0.467. So that gives us the predicted value, which is very close. So what we're going to do, we're going to click here and drag this down all the way to that arc length. The residual is the difference between the actual data minus the predicted value by the model. So basically, the residual is equal to actual data, click on this one, minus the predicted value. So what we're going to do is click here and drag it all the way down. So that gives us the residual. All right, so we created the residual. What we want to do, we want to graph the residual and the X variable. So I'm going to highlight, I'm going to copy and paste this one here. And it prompts us, do you want to paste values only? Yes. We go to residual, well, the same thing. So we highlight the whole column. Or that piece, we're going to bring and copy paste it. And it asks us, do you want the value only? Yes. So we want the residual graph in terms of the X value to be a random graph. So let's go to insert. We're going to go to chart. And not the column chart, we go down to Scatterplot. We want that the scatter plot to be very random. So I missed it. So when you look at this point, there is no pattern. The points are all over the place. So that tells us that the linear model was a good model for this data that we were looking at. So that's how the residual plot makes sense. The next question says the class length is 6400 millimeter. Use your regression equation to predict the number of beans required to cover the class length. So 6400 millimeter is the length, the Y variable. So let me move this residual plot. So we have 6400. So looking at the Y variables, we see how we go up to 265. So when it says 6400 millimeter, we are using, we want to predict the number of beans based on the model that we have. So to predict the X variable, we want to plug in Y equal to 6400. So If I go here, we have our equation. So to calculate it, we're going to have 6400 equal to this equation that we have, which is, let me bring it up, 13.2 So we want to solve this and find the x value. We subtract this by 0.467 and remove this one from this side. And then we're going to divide that whole thing by 13.2. And you want it to subtract those two divided by, so we get 484. So based on this model, it takes 484 beans to cover the length of our class. All right, hope this was helpful. Let me know if you have any questions.